Hi, I've promised you a film on synthetic aperture radar, SAR. I was contacted by quite a secret source who obviously works in that field, who suggested I made a film about it. And I've been researching it for over a year. Now, I'd like to do a film about how it works. You know what? This is how it works. It's extremely complicated. So I've decided to do a film about why it came about and what it can do. It's fascinating. It literally is a link between Tesla, Hillary Clinton, and Howard Hughes. I mean, it's just the story of synthetic aperture radar is one of the best. Now, in a slightly different format today, I am going to try and tell you that story to camera. I'm going to mess up. There's going to be jump cuts. I'll try and illustrate with stills as much as I can. But here goes. Okay, so radar. Well, first of all, before radar, Tesla, great man, a lot of people still like his work and is very interested in him, came up with his so-called death ray. Probably it was an electromagnetic spectrum frequency radio wave that he discovered that could be propagated, aimed at, say, blimps or aircraft. This is way back, and used to set them on fire. The British government took it seriously and asked some scientists to actually build a death ray. Now, they didn't. Of course. They discovered you'd need so much power to actually send a beam up and destroy an aircraft. But one of the scientists, Robert Watson Watt, found that while experimenting with the so-called death ray, by sending microwave energy out into the air, he got it bouncing back off early aircraft. This is in Britain in the 1930s. And it was amazing. So he went back to the British government and said, I really don't have a death ray, it's not going to work. But I've invented this thing that can detect an aircraft in the air hundreds of miles away. Radar. Brilliant. Now, the story of radar from then on is just one of my favorite. You all know carrots are good for your eyesight. And in Britain, in World War II, a lot of posters came out saying, carrots help our airmen see in the dark. No, they didn't. It was a piece of misinformation because early British fighter planes had radar on the nose that could detect German fighters at night. This was a top secret program. One of the fighters was even called Cat's Eye Cunningham because he was so good at flying British airplanes at night and shooting down German planes. In fact, he had early radar. The earliest radar literally just sent out a beam. A bit of it might bounce back, and on a scope you got a blip of where the bounce was, and you could kind of steer the beam and triangulate to where the object you were looking for, say an aircraft, is. Scroll forward. Cold War. So the Cold War really wanted to have a incoming nuclear ballistic missile program. And this was the DEW line, or Defense Early Warning Line. And these were massive ears, big fixed radar dishes focused at one position, the position that they thought intercontinental ballistic missiles would come over the pole towards North America. And these were standard radar dishes. They used these amazing buildings and this technology called SAGE, these cuboid concrete square buildings with these round cathode ray display radar screens, and they're still there today. I know one in Madison, Wisconsin, which is now part of the university, and we've just had a guest for this Liberation of France celebration that I was talking about, who still works in one at Minot Air Force Base, no longer a SAGE headquarters, now part of the accounts department. Times move on. One of this Dewline Defence Early Warning buildings was in Britain, and it was in a famous place in northeast Yorkshire called Fylingdales, and these iconic domes, which we all know in Britain, housed radar dishes which were just looking at Russia. CIA, Howard Hughes, and spying. Now let's just have a quick kind of recap on early spy satellite resources. Wouldn't it be wonderful to fly something over in space that couldn't be tracked, to look down and count missiles and planes in Russia? One of the earliest programs was called Corona, and that it was launched from Vandenberg Air Force Base, and it had Polaroid Corporation, not instant developing, but Polaroid made wide format film, an incredible high quality lens, in a satellite that would fly over a set place in the world and take snap photographs. You needed to get the film back. Film at the time, film and, high quality lenses was the best thing available. There was no electronic cameras, and there was certainly no way of transmitting the data from the satellite back to Earth. So you shot it on film. But how do you get the film back? Well, the Corona program ejected the capsule containing the film before the satellite burned up in the atmosphere, and the capsule containing the film came down on a parachute. You kind of knew roughly where it was. It was mainly in the Pacific, quite near the island chain of Hawaii. Planes would fly out with this kind of wire trapeze behind it and scoop up the dropping capsule. If they missed it, the capsule would land in the sea and give out a radio beacon. But of course the Soviet spy ships would try and look for it. So the capsule had a salt plug that would slowly melt, and after a few hours or days, I don't know, it would let in water and the capsule would sink to the bottom of the Pacific and all would be lost. Now, the real secret story behind Corona was, okay, it was a DoD government program, but the idea and the funding came from Howard Hughes. Howard Hughes was, of course, an extremely rich man, made money from royalties he got from hiring out drill bits for the oil industry. In the later days of Howard Hughes' slightly sad life, he lived as a recluse in his penthouse in Las Vegas, and in the penthouse was a home cinema. And supposedly, he watched almost every day, and certainly it's well known it was his favorite film, is a film called Ice Station Zebra. You might have seen it. What's special about Ice Station Zebra is that it's about a capsule that returns to Earth in the North Pole, in the Arctic, and two submarines pop up through the ice cap. Remember, the North Pole ice is just floating sea ice, unlike the Antarctic, which is on bedrock. They pop up, and the film is about the Russian and the American submarine commanders trying to get back the film from the Corona program. Now you understand why Howard Hughes loved that film, because it was actually a film about his Corona program. So you've got these film cameras with lenses doing spy photography. Satellite spy photography and surveillance has two obvious problems. A lot of the places they want to look at are covered in clouds, and optical technology cannot see through clouds. The second, it's quite often night. They can't really see very well details at night. The holy grail of satellite surveillance technology would be this: a satellite that can see through clouds, see at night, and send back its data like a live TV picture in real time to the commanders who are looking at the mission that that satellite's observing. That in the 1960s and 70s and 80s was a long way off. But along came radar. Now, radar is basically just an electromagnetic radio beam in the microwave spectrum, bandwidth I should call it, that propagates a signal and it bounces back off something. But with a lot, and I really mean a lot, of signal processing, you can actually get a visual image of what the radar beam is bouncing from. It works at night. It goes through clouds. And you can send back the radar signal in real time, process it, and look at the pictures live-ish. Wouldn't that be amazing? But we were a long way off making that work. The first thing that happened is that satellite dishes stopped being these either enormous ears pointing in one direction, and then became these parabolic dishes that you could move up and down, left and right, whatever, or all the way around. But they were big, heavy stuff. Then came out phased array. And you've probably seen these. These are flat mesh type radar dishes with lots of sensors on. And you can electronically move the beam down all the sensors to scan the part of the sky or whatever you're looking at. So that was the beginning of it. Then came what we're talking about today, synthetic aperture radar. I still don't understand why it's synthetic, why there's an aperture. I believe it's really complicated. You understand it. Try and explain it to me simply. But what it can do, I can talk about, and it is amazing. And also how the image is processed and sent back to analysts is the real point of this film. We've talked about this on this channel before. NASA is, a government agency. It's totally connected with the Department of Defense, and many of NASA projects are DoD defense projects, the shuttle being the classic one. But one of their missions was a mission to do a radar telemetry of the surface of Venus. And in fact, the satellite that they chose to use was an early LaCrosse type radar imaging satellite, which later became the radar satellites that look down on us. So no doubt these SAR, synthetic aperture radar satellites, got better. They could see at night, they could see through clouds, they could send the data back, in high quality, large amounts, data streams back to processing centers, but they're really hard to process. And the images were, if you look at a raw SAR data, I mean, it's far from being a visual picture, but it has some amazing and slightly counterintuitive things that a radar can see. First of all, it's very good at seeing three-dimensionality. And if you get a couple of these, or like a fleet of these radar satellites, and look at the same target, you've got a 3D image that you can process where you can turn it into a picture and then rotate it. And, you've probably seen on Google Earth, if you go into some of their big cities, you can kind of fly around and actually in 3D go around the city and turn it around. That is synthetic aperture radar technology that you are allowed to use. But imagine the resolution the military have. But there's a price to pay for this. And this is one of the two areas which this viewer shared with me, which I really can't share everything that he said to protect, literally we're talking about cutting edge military technology, and I'll just be general about it. So you've got this constellation of SAR satellites up there. They're seeing things in 3D. They're seeing at night, they're seeing through clouds. And say there's a mission such as the attempted assassination of Osama bin Laden in his complex. People in control, we've seen this classic picture, would like to see the mission unfold in real time. You can. You focus your SAR satellites onto the Osama bin Laden complex area. You get a 3D real-time image of the mission. Here they are watching it. And you crank up more power in the processing centers than you can imagine. So hidden in the United States, and no doubt other countries have them as well, are the SAR imaging processing centers. They get this raw data, which is unbelievably raw, back from the satellites and turn them into colorized 3D moving pictures in real time, probably near real time, a few seconds delay, no more, of a close-up of helicopters, troops, vehicles, buildings on the ground. So military commanders can actually watch a mission live. All right, here's a little kind of secret thing that he told me that I can share. The problem is these servers are so big, use so much power, that when a mission is unfolding, they ramp up the servers to do the processing, and blip, 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 all these hotspots in undisclosed locations to you and I get hot. Our enemies can see that from space, so they know that there's some important mission going on. They also can, probably eavesdrop on the SAR downlink. I don't know if they can process it. Probably it's encoded really heavily. But the servers give away that something is going on. So they put them on the ground. So if you ever see a couple of cars parked in a field, a small building, and then your local bar, 3 or 4 kind of nerdy computer guys, and you don't know what's going on over there, it's probably an underground SAR processing center. Now, interestingly, the processing centers probably don't need to be manned very much. You probably just need a good air conditioning technician and somebody who can fix computers. So there's not very many people there, so they're pretty secret. They might even be a bit like the underground missiles. You just go there to service them now and again. I guess it makes sense to put them in northern parts of the US, Alaska, the northern border with Canada. And also I know that they're going to have to be near some massive power generation plant. So maybe natural gas in Alaska, fracking, whatever. But if you've got like the hole in the ground and a little power station, you've probably got a SAR processing center in your backyard. And that's as far as I'm going to go on that one, because I know where some of them are, and I'm just not going to say on YouTube. This is a world open channel. But what I'm going to tell you now is unclassified, but is really cutting edge. You can read about it online. I've checked. I don't want to break any rules. I'm not a whistleblower. I just think it's fascinating, and I think it's useful for people to know the kind of level of technology that is out there. Because SAR, synthetic aperture radar, has an amazing secondary capability. Here's my statement. SAR can track the mass, the weight, shape and size of metal. Right, seems quite an innocent statement, but with that technology, you can look at things like how many new electric engines in, say, Nissan Leafs are being produced. And here's what the secret source told me. I have no idea if this is true, but it sounds like an experiment which people would try. So imagine one of the people that you're interested in has a metal ring. If you know its exact weight, its mass, SARS can find it supposedly. Imagine if you just want to track somebody wearing a ring, your ground spy assets weigh the ring absolutely accurately to a few micrograms. You type in that exact weight and go, where is that exact weight on the planet Earth? There's a guy wearing the ring. I also believe that things like the president's car, or in Britain the Queen's vehicles, are an exact known weight. So you can type in that weight and you've got real-time tracking of a metallic object. Also, in a military field, say there's been a battle using a lot of shell cases, you can find all the shell cases, and then if vehicles, say, drive over the old battlefield and the shell cases move, you can tell that they've moved. So you've got this kind of time-based reality by measuring where metal is. That's really, really interesting. Now, I'm probably just going to push my luck here, but I'm going to say it. So you know now that SAR tracks the mass of metal. I'm not going to say what part. I'll leave it to your imagination. US military uniforms are a known weight, have a known metallic content. You can track your troops. Well done, synthetic aperture radar. Well done, scientists, for making this work. Clever people in server farms. It's a fantastic technology, and I hope it is actually even better than I know about. So thank you for watching. I hope I haven't given away any secrets. And if you can explain to me and everybody watching how it really works, please do in the comments below, because the truth has to be out there.